Welcome to classes on physical chemistry. Today's class is class number 26 and it is the continuation of class number 25. And I have taken the chapter solution on physical chemistry, higher secondary second year. So the chapter solution in a very precise manner, I will explain the theoretical part today and next numerical problems in one shot, 40 minutes. So first of all, the chapter solution, there are lots of solutions. There are lots of types of solutions. But out of these solutions, we'll take solid in liquid, liquid in liquid, and gas in liquid. So before that, in a very precise manner, I will tell you something about, in a brief manner, solubility. What is solubility? Now, before coming to solubility, let me take some of the molecule, say ammonia. So I have taken two types of substances, molecules. One is ammonia, one type is ammonia sulfur dioxide hydrochloric acid. These are the polar molecule, each and every one of you know, and these are very easily liquefied. And the molecules which are very easily liquefied, those are polar molecules, they are very easily soluble. Very simple. Number two, sulfur dioxide is a gas which is also soluble, and this is soluble under pressure. Now there are some factors on which solubility depends. Number one, temperature. Number two, pressure. Number two, mass. In short, I will tell, because we will be very explicitly concerned with the pressure, but still I will tell something about temperature. So what's happened if on increasing temperature solution of the gas molecule, I am taking the solution gas molecule in liquid, temperature, if we increase the temperature of gas molecule, the solubility, what will be the extent of solubility of the gas molecule? The solubility of gas molecule will decrease if you increase the pressure. Just I will give one example. Say gas so whenever gas molecule is dissolved in the solvent, it is found that when the gas and solvent parts, a solution occurs, that the reaction is del H is equal to negative this, it is exothermic reaction. And here we will apply the concept of Le Chatelier's principle. What Le Chatelier's principle tells that for an exothermic reaction, high temperature, and this part is important, I will tell again in later part, this concept will again come. Gas plus solvent, when gas is dissolved, we will get product, dissolved gas in solvent, and it is an exothermic process. According to Le Chatelier's principle, if we increase, the equilibrium will shift towards left, that is, the product part will again convert to the reactant part. Am I right? So we see at higher temperature, the gas molecule will not be dissolved at greater extent, as the equilibrium will shift towards back. Pressure. So on increased pressure, gas molecule, the solubility of gas increases. Solubility of gas increases with increased pressure, and we will a bit later we will discuss it in detail. Solubility of gas increases with some gas, not all gas increases with increase of pressure. Now mass, it is not too much important for you, because those molecules which are not ionic, non-ionic, so to some extent, if you see that these non-ionic gas molecules are dissolved in the solvent, then what's happened if the mass of this gas molecule, this molecule increases, what's happened? Their London force, if mass increases, London dispersive force and device force increases, and due to increase of the masses, London dispersive force and device forces increases, and the extent of the solubility of gas molecule with increased mass decreases. This is in a very simple way I have mentioned some of the factors and solubility. Now let us come in a very elaborate manner the solubility of gas in liquid. Henry, he was a physicist and chemist of British physicist and chemist. He gave a explanation. I am not giving you the statement of the Henry's law. It will be explained from the mathematical formulation. So you see, a lots of the mathematical formulation of Henry's law is the mass of the gases dissolves is proportional to the pressure, and pressure is again proportional to the fraction. Mole fraction, mole is the mole fraction, mole is the partial pressure, and the concentration. Again, it can be written in terms of concentration. The more is the mass of the gases. That is, more is the mole fraction dissolves under mole partial pressure, mole pressure, vapor pressure pressures, and then concentration also increases. That is, concentration of the gas molecule dissolves also is directly proportional to the pressure. Also, solubility of gas molecule directly proportional to the pressure. So if you take out write in this way, P is equal to K into KH into X is the mole fraction, then we can write K is the Henry law constant. Am I right? So this concentration C equal to KH by P, and like this we can write solubility equal to some constant into P. We can write a lot of formulations of Henry's law. So more is the pressure, more is the solubility of the gas, more is the pressure, more is the fraction, mole fraction of the gas molecule dissolved in the solution, more is the pressure, more is the concentration of gas molecule in the solution. These are different formulation of the more is the pressure, more is the solubility of the gas. Am I right? So what to tell from here is that what is the validity of this law, and what are the grounds under which it Henry's law holds good. Number one. So these are some of the factors of if these factors are fulfilled, then Henry's law will hold good. Number one is under low pressure. I will draw a graph, then I will explain it. The pressure should be low. Number two, gas molecule should not be chemically reactive. Number three, there should not be association or dissociation of gas molecule in the solution. Number four, temperature should not be too high, but high should not be too high. Then next one is not directly but indirectly is related to the condition of Henry's law is the solution should be diluted one. So from the law we get this is mole fraction, this is pressure, this is KH, Henry's law constant. So another factor is very important, very often asked in entrance exams, also in the class exam, that if the value of KH is higher, the solubility of the gas molecule will be lower. It is inversely proportional. You just keep it in your mind. If you draw the graph, mole fraction abscissa and ordinate P, then partial pressure here and mole fraction is here, the graph will be like this. Now another part, important part, where very often questions comes in entrance also as well as in your class exam, the fact is application. Very important, very often question asked. Number one, minorly just you follow, needed to learn by heart. Just you listen, you can answer yourself. This chapter is very simple and very easy. In the next chapter, when I will solve out the questions on the numerical problems, I will give you trick with the help of 2 or 3 formula. You can solve out each and every one formula. Don't be afraid of the numericals of solutions. I assure you, I can show you the trick. Application, out of the application of the partial pressure, we have established or shown the relation of statement in the mathematical form of Henry's law, and from here we have seen there is a relation between partial pressure and mole fraction. Then with the help of this we will explained pressure and this, we have explained the carbon dioxide. When the bottle of the cold drinks is open, we see that carbon dioxide rushes out with a very vigorous speed. This is because of the fact that when gas carbon dioxide is dissolved under high pressure, and when the sealed bottle cork is open, the pressure instantly upon the surface of the molecule decreases. As pressure decreases, the dissolved carbon dioxide gets free and they starts bubbling out of the reaction. This is out of the solution, and this is the reason that the carbon dioxide forcibly comes out. Now, next one is very important, bending effect. In the textbook, it is given bending effect. To release the bending effect, helium is added. But what actually bending effect is, I am telling you that is scuba divers, scuba divers very often use the cylinder of oxygen. And what's happened when in the cylinder of oxygen, then along with the oxygen there is nitrogen mixed up. So at very high pressure, when they go bottom of the sea, the pressure increases in a very tremendous manner. So with the along with nitrogen, oxygen, but nitrogen are very efficiently mixed with the blood. And when the nitrogen mixed very easily with high pressure, then what's happened? The nitrogen gives you narcotic effect, and that effect is intoxicating effect. And am I right? Now, when they start to ascend up, sea level is sea level. From this point, ascend. If they increase the speed, the pressure increases. Pressure increases in this manner. When they tries to ascend to the surface of the water, by due degrees pressure starts decreasing. As pressure decreasing, and if they ascends quickly, then in a quick manner the pressure starts decreasing. So under less pressure, the dissolved gases starts evolves out with greater speeds, and thereby they creates bubble. And due to the creation of that bubble, it creates disturbance in blood circulation. Am I right? And due to this disturbance, there is a pain feeling. Am I right? So this effect is called bending effect. Now what's happened? To escalate this effect, helium is used, which is less soluble under pressure, in order to escapes out or prevent the scuba divers to ascend freely without any pain. Decompression. When decompression occurs, the gas molecule starts evolving out under low pressure with a vigorous speed, creating bubbles. And to minimize the paining effect or bending effect, helium is used. These two questions are very often asked in exam. Another one is, warm or cold water is good for aquatic animals? Answer: cold water is good for aquatic animal, because we have already explained that when gas molecules are dissolved, it is exothermic process. When temperature is increased, the equilibrium is shift towards back. Am I right? So dissolved gas molecule will evolves out. Am I right? So in water there is dissolved oxygen. Am I right? So at at temperature, or when water is warm, the water is harm, there will be deficiency of hydrogen, so they will find better to live in cold water. So these are the some important application of Henry's law. Everybody know what is vapor pressure. Very simple way I am telling you the what are vapor pressure. Water transforms to gases in gaseous form, and again gaseous form to water form. When these two form, one is water to gaseous form and gaseous to liquid form, are in equilibrium. So the vapor at this equilibrium state, when vapor of the solution exert a pressure upon the surface of the solution, is called vapor pressure. When these two are in equilibrium, these two rates are in equilibrium, then the pressure, the vapor exert pressure upon the solution is called vapor pressure. Now, this vapor pressure is very important. Raoult's law. Along with the mathematical expression, I will give you this statement. Partial pressure of the volatile. Here you will mind that The partial pressure of the volatile component dissolved in the solution is directly proportional to the mole fraction of that component at a particular temperature is called Raoult's law. The partial pressure of volatile component present in a solvent in a solution is directly proportional to the mole fraction of that component at a certain temperature is called Raoult's law. Means when partial pressure increases, mole fraction increases. When mole fraction increases, partial pressure increases. Am I right? So what's happened? If we assume that when a volatile component is present in a solution, and if this in the solution the component is assumed to be one component, then solvent itself is a solution. That solvent is nothing but a pure solvent. When there is only one component, it is pure solvent, and that pure solvent, if it is one, so partial pressure of that component is nothing but the partial pressure of pure component, because there is only one component. So that Pa becomes Pa naught K. So Pa is equal to it is the mathematical formulation of Raoult's law. Now what's happened? If you take another component, binary component, so you will get these two. So according to Dalton's law, total pressure is equal to P1 plus Pb. So that is equal to so if I just add up, we will get this one. Am I right? Now mole fraction will give me 1. Total mole fraction is nothing but 1. So if I take XA is equal to 1 minus XB. So if you put Pa naught we get that total pressure is equal to Pa naught plus Xb into Pb minus Pa naught. Or in this way, if we replace Xb by 1 minus Xa, we will get another relation. Am I right? This is something about Raoult's law. Now, one of the important thing that will become in need to explain, if we have taken in consideration the component which is added in the solution is a volatile component. If we take B a component which is non-volatile, now what's happened? You see, what is the relation of vapor pressure here occurs. Now the component we assumed as a non-volatile one, if the component is non-volatile, then this part must be 0. There is no polarity, no partial pressure is there. Am I right? So we get total pressure P is equal to pressure due to a component. Am I right? And pressure due to a component is equal to, again earlier we have shown seen that Pa is equal to Pa naught into X of A. Am I right? So now I want to tell you one of the interesting fact. Very often in colligative property we'll get a bit later, that on addition of a non-volatile solute in a solution, the vapor pressure of the solution what's happen decreases. So depression of decrease of vapor pressure when a non-volatile component is added in the solution. So let me explain why the partial pressure, vapor pressure of the solution decreases on addition of a component which is non-volatile. Why? Earlier in case of we assumed volatile component, now we are adding some component which is non-volatile. Mind that. So what's happened here? We know XA plus XB is equal to 1. Therefore, XA is 1 minus XB. We needed to do these things, means apparently from this relation we see that XA is nothing but less than 1. XA is less than 1. So if XA is less than 1, say it is half. Say it is half. So P is equal to PA naught, it is half. So what we get? PA naught is equal to twice P. Means PA naught is greater than P. So the pressure of the whole solution is less than partial pressure of the component present in the solution. That has occurred only due to placement of a non-volatile component in the solution. Am I right? So when a non-volatile component in the solution is introduced, the pressure of the solution decreases. Pressure of the solution decreases due to this fact. But also it is explained in your textbook that when a non-volatile solute is introduced in the solution is mixed to the solution, then that solute particle occupied some of the space of the solution surfaces, and this decreases the solution surface and volume area of the solution surface, and hence there less remain and less amount of the surface area, and since surface area is less, so vapor pressure of this surface area will be less. And mathematically we can explain that on addition of the B component or a component which is non-volatile, the vapor pressure of the solution decreases to some extent. We can say, if you draw the graph, we find so if you look at the figure, you see this line gives you the Raoult's law. If you draw the two components, then these two components, there will be 1 and there will be 0, there will be 1, there will be 0, and this will be from left to right will be the X component, and from right to left will be this component, B component. You need not to make it clumsy. So simple way, you give the mole fraction at abscissa and you ordinate the P represent abscissa. So at this point we see non-ideal solution graph is this, and Raoult's solution graph is this, and Handy's graph is this, and these three graphs has just met at the same point, meet at the same point here where the pressure is very low, so also the concentration is very low. When pressure is very low, then the mole fraction will be less than 1. So at less than 1, which tends to 0. So limit x tends to 0, P by x equal to k. So three graphs in one slot I have. Yes. Now ideal solution. So one of the my advice is that you need not write to any theory. Just you write in mathematical form, you stick the point, you will get the marks. What is ideal solution? How what are the conditions? No need to write. Just I am telling you, right? Ideal solution means, before that explaining ideal solution, let me take one example, A and B. Let us take two solution. Say one is benzene, other is toluene, maybe other thing. Am I right? So to get mix up to give a solution, there should be intermolecular force between A and B. Am I right? So it is interaction between A and B. Again, besides A and B, there is AA interaction and there is BB interaction. So a lots of toluene molecule have a lots of BB interaction and lots of benzene molecule has a interaction. So there are two types of interaction. One is interaction between the same molecule, other is interaction between the different molecule. So these things you keep it in your mind. And now let me explain what is ideal solution. That if it is ideal solution, if to mix up after mixing up of these two solutions, if it results a ideal solution, then Raoult's law should follow. So PA is equal to PA not by X, PB equal to PB not by X. Number one, condition number one. Number two, the A interaction is the same as if this condition is fulfilled, first one this and second one is this. If AB interaction is the same as A interaction, BB interaction, so there will not be any increase or decrease in the volume of the solution. Individual volume 5 ml, 5 ml, it will give 10 ml. Am I right? And number three, if these two are followed, then del X del B mixing equal to 0 and del H mixing is also 0. So these are the conditions. If three conditions are fulfilled, then it is ideal solution. Now what is non-ideal solution? Non-ideal solution, again it is very simple. You see, if it is non-ideal solution, you don't write, you write here non-ideal solution. PA not equal to PB, PB not equal to PB not equal to this, and AB is not same as AB interaction is not intermolecular attraction interaction is not same as AA and BB if it is non-ideal, and del X mixing volume may be greater than the 5 ml, 5 ml, 10 ml, may be greater than 10 ml, maybe less than 10 ml, that is not equal to this, and del X mixing also not equal to 0. It may be positive, it may be negative. So this is non-ideal solution, nothing theoretical part is needed. There is two deviation from ideal solution. One deviation is positive deviation. Positive deviation from ideal properties, other is negative solution, negative deviation. Now what is positive deviation? Now with the example, with the help of example, I will explain what is. Now in this case, when there is deviation of the wrong, so there are two types of deviation. One is positive deviation, other is negative deviation. What is positive deviation? In which PA is greater than PA not B and PB is greater than PB not equal, greater than this is the first condition. And AB interaction is less than A interaction and BB interaction. A interaction, this molecule between molecules, same molecule interaction is more, they are not much active or intend to get mixed up. Am I right? Now why? Because you see, let us take an example of ethanol and cyclohexanol. So ethanol has a hydrogen bonding, am I right? So their AA interaction is much more, am I right? And there is no hydrogen interaction, and that molecule cyclohexanol creates a problem or difficulty or hinders or prevent the extent of hydrogen bonding here. So due to this fact, some amount of CH2H or C2H5OH molecule remain left out in excess, and that excess molecule escapes out, and due to the presence of this, the vapor pressure increases, the volume increases. Due to presence of excess, due to the hamper of hydrogen bonding, and the some excess H2H, A5 or C2H5OH remain in excess, and this excess gives rise to higher vapor pressure, and that gives rise to volume, increase in volume. That's why del H B is equal to positive. Say 5 ml this and 5 ml this. After this, you will get something not 10 ml, something more than 10 ml. That is change in volume equal to something plus. And what's happened when these two molecules A interaction is less than BE interaction? That means they are not willing to get mixed. If some amount of energy is to be supplied to get the molecule in the involved in the solution. That's why if amount of energy is required to be supplied, that then del S mixing is the positive, that is it is endothermic reaction. So you can write it is endothermic reaction. So if it is positive deviation, this is very simple things, no need to write any description. Now what is negative deviation? Negative deviation. So here we'll write say it is chloroform and it is acetone. Am I right? So in this form of reaction, this is A and this is B. Here, due to existence of hydrogen bonding between AA molecule, the force of attraction or interaction is bigger than AA, chloroform and acetone. This means from AA and BB interaction, from molecule to molecule, the interaction A and B is the more due to the hydrogen probability of availability of hydrogen bonding, and since the strength of this bonding is more, the bond is tightly in the remains in the solution. Thereby, what's happened? The volume get reduced. So here this part you just change. Am I right? Here AB interaction is less. You will write AB interaction is more than AA and BB. Del X mixing is not positive. Del X mixing is negative, means there is less in volume, final volume is less, and that is negative. And here it is, since it is negative, it is exothermic reaction. So this is all about the ideal. So before talking about another facts, first of all you should know what are colligative properties. Maximum of you do not have the concept on this one, so first of all you clear out from here. The properties of the ideal or dilute solution depends upon the number of solute present or on the molar concentration of the solute at certain temperature is called colligative property. There are some property we are going to mention, that this property will chiefly depend upon the number of the solute present in the solution or the molar concentration of the solute present in the solution, and this property which depends upon the number of solute particle or the concentration, molar concentration of the solute present in the solutions are called colligative properties. So the example of colligative property is, so I have just given you one example. There are 4 properties also in your book. It is mentioned: lowering of vapor pressure, elevation of boiling point temperature, depletion of freezing point temperature, and osmotic pressure. And minutely follow these things, and upon this one lots of questions are being asked in the exam, and so also lots of mathematical problem will be from there. So I will deduce some of the facts here, and individually one by one I will explain what is lowering of vapor pressure. So mind that lowering of vapor pressure means, at the very beginning, a bit earlier I have told you, when the solute, which is a solute, is non-volatile solute, is mixed in the solution, then vapor pressure of the solution get reduced, and this is called lowering of vapor pressure. So we will take a component B, and that component B is non-volatile in the solution, and we will see what is the effect of this introduction of this non-volatile solute in the solution. So the solution that is equal to P is equal to PA naught, equal P is equal to PA plus PB, and since P equal to PB is equal to 0, so we get P is equal to PA because non-volatile solute B as Pb is equal to 0. So P is equal to only Pa. So Ps is the pressure of the solution, that is equal to Pa, and that Pa by Rolle's law Pa not into Xa. Am I right? So what we get here is P is equal to Pa not Xa, as earlier we will do like this. So this is very simple, but minutely follow these things, that you should not avoid this one. You should know how this has come, because this will very often come in numerical problem solution. So minutely follow. We have written PS means solution, total pressure, partial pressure of the solution is equal to partial pressure of the one component, that is non-volatile component B has partial pressure 0. So Pa plus Pb equal to Pa. So Pb is equal to 0. So Ps is equal to Pa, and that Pa equal to also equal to Pa not into Xa. Am I right? So you see Ps equal to Pa not equal to X. We have just taken it Ps by Pa equal to 1 by this. Here I have changed the sign, minus Pa equal to this, and I have taken this one, and from this we have got Pa Ps not equal to Xb. This is very important fact. So here Pa minus Ps naught, it is change in partial pressure, and that is not colligative property. It is not colligative. It is not colligative property. It is not colligative property. But A Ps by A, this is relative. Am I right? This is relative lowering. The change in the vapor pressure divided by Pa naught. It is relative. It is ratio. That relative is the colligative property. So lowering of vapor pressure is a colligative property. This is colligative property. Mind that. So what I am now going to calculate is again important. Mind that from the earlier relation, just I have taken PA minus PS by PA not equal to relative lowering of vapor pressure equal to one component. Similar way we can take XB or XA also. So you see, and from that I have just taken PA is equal to PS in order to relate it with the molecular mass and molecular mass of the component added. So we have written this equal to this, and that is mole fraction SB is equal to number of mole NB divided by total of the mole N plus NB. It is known to you. Just I have written this equal to this. Am I right? So I have just reversed it. I have taken numerator above and below. I have just taken this one. So after this, just I have divided individually. I have got this one. So PA by PA naught minus PS equal to this. Then I have taken one back. I have taken this one, this. From this, we can LCM. We have got PS equal to PA into PS equal to NA by NB. So again, I have reversed this one. So I got NB is equal to NB is equal to NA, and what is number of mole? Number of mole equal to weight divided by molecular mass of that component. Weight molecular mass of that component. So if you rearrange it, you will get UB UA MB. So we have got PA naught minus PS by PS is equal to WB MA WB. This is the solute which is dissolved, which is mixed, and this is the molecular mass of that solute. And this is the molecular mass of solute A, and this is the solute which is dissolved, and it is the molecular mass. This is the relation with the molecular mass, and it is very often used in the mathematical formulation. So you please. So before understanding the boiling point is raised, the boiling point, if it is earlier something, it will be raised at higher boiling point, it will be boiled. Why boiling point is elaborated? Boiling point of boiling the temperature at which it boils. At which it boils, or in a very simple way, but in a more complicated way, the vapor pressure of the component on the surface of the solution, the vapor pressure of the component of the surface of the solution becomes equal to the external pressure. When these two, external pressure and boiling pressure of the vapor pressure of the surface of the solution, after adding of the non-volatile substance B, when these two becomes equal, at that point it boils. Am I right? Now, why boiling point is elevated? Only because of the fact that when, so earlier we have already mentioned, when a non-volatile substance or component is added in the solution, its vapor pressure decreases. So to make the vapor pressure equal to that of the external pressure, we need some amount of energy is to be supplied, temperature is to be supplied. Because on addition of the non-volatile substance B, the vapor pressure of the solution has already reduced. So to boil it means to make the vapor pressure equal to the external vapor, that is at this point it will boil. We need some amount of temperature to raise the boiling point and to make it equivalent to the external vapor pressure to make it boil. So on addition of the solute, non-volatile solute, vapor pressure decreases, and to make the vapor pressure increase and to make it equivalent to the external pressure, we need some amount of temperature to be supplied. That's why vapor temperature is elevated. The boiling point is elevated. Now that boiling point is, if it is elevated, TB and I'm not deducing it, that TB naught is equal to KB into this, and this is called ebuloscopic constant or molar elevation constant, ebuloscopic constant. And here that M, it is, later on I will replace it by another term, and the relation will be something changed when I will take an example in solving the problem. Depression of freezing point. Depression of freezing point, that is freezing point, is again represented by M. we will explain later on in mathematical part. Next, osmotic pressure, the tendency of movement of the particle from solvent to solution, or from dilute solution to concentrated solution, or from lower concentration to higher concentration. It is called osmosis. The movement of the particles from solvent to the solution, or from dilute to the concentrated, or from lower concentration to higher concentration is called osmosis. Now, what is osmotic pressure? What is osmotic pressure? Osmotic pressure, that it is a normal and general movement when two solutions of different concentrations are made in contact with each other with a semi-permeable membrane, that there will be movement of the particle from one solution to other. Am I right? Now, after some time, what's happened? The movement of particle from one solution to other solution stops, and at that time a pressure develops. The pressure which is developed on the solution when the further movement of the particle from solvent to solution, from dilute solution to concentrated solution, from higher concentration to lower concentration stops, that pressure is called osmotic pressure. The pressure which is developed upon the surface of the solution, for which the movement of the particle from solvent to the solution, or from dilute solution to the concentrated solution, from higher concentration to the lower concentration, is called osmotic pressure. So now when we have come with osmosis, then we will come with osmotic pressure, and then we will be reverse osmosis. So if the osmosis is from particle from solvent to the solution and from dilute to the concentration, reverse osmotic process will be, osmosis will be the reverse of these things, from concentrated to the dilute, and from higher concentration to lower concentration, from dilute to from solution to solvent, and that is called reverse osmosis. And reverse osmosis only defined for desalining of water, seawater. So, depending upon the fact of osmosis, there are some terms. Egg, so when if you remove the outer shell of the egg, and if we place this part of the egg, so the protein part of the egg has higher concentration than in water. So if you place that protein part of egg in the water, so the semi-permeable membrane of the egg, water, it is highly concentrated, it is less concentrated, the water particle will move from water to egg, thereby the size of the egg will increase. And this is called osmosis. And if you now take this egg in the salt solution, now concentration of salt solution is more than this. Now the protein particles of the egg will move from egg to salt, and that will shrink in size. And this is called exo-osmosis. So we have got two things. Very often this question is asked in your class level or in the final exam cell. Why size of the egg when it is placed in water is increased? This is due to osmosis. And why egg when placed in the salt solution becomes shrink in size? This is also due to osmosis, and it is exo-osmosis, and this is endo-osmosis. Yes, isotonic solution, there are two solutions of same molar concentration, has same osmotic pressure, and these solutions are called isotonic solution. That is, solution either they have same osmotic pressure, that is they have same molar concentration, are called isotonic solution. Now if one solution has less osmotic pressure, that is less molar concentration than the other, it is called hypotonic solution. And if one solution has more molar concentration, that is more osmotic pressure than the other, it is called hypotonic solution, and these two, hypotonic and hypertonic, these two solution has a lot of implication and application in our biological system. Let me take one example. It is seen that blood plasma or blood cell consists of a lot of species inside it, and this blood cell or blood plasma has concentration 0.9%, and if you can make the aqueous solution of sodium chloride 0.9%, then these two solutions are hypotonic. Their molar concentration is the same, that is osmotic pressures are the same, so they are hypotonic solution. Now, why I have taken the example of these two? Only because of the fact that so the injectable substance which is required to be injected inside the human body are always mixed with 0.9% solution of sodium chloride, because our blood cell or blood plasma has the percentage of molar concentration percentage equal to 0.9%. So if these injectable substances are mixed with 0.9% solution before injecting, then the blood plasma concentration and the concentration of the injectable substance with sodium chloride has the same concentration. So there will not be any flow from blood cell to sodium chloride solution with injectable substances, or from injectable substances to blood plasma. That will work in a very good manner. Now, one problem is there. Now, if we do one thing, then blood plasma or blood cell, if we make contact with pure water, what will happen? The concentration of pure water is less than blood plasma. It is 0.9%, and hence the pure water has less concentration. It is solvent. So the water will move to pure water will move to the higher concentration. Am I right? So what will happen? The cell will swell, and that swelling of cell is called hemolysis. Now again, another fact is here very important. Now very often you will find that the doctor very often advise the patient, those who are suffering from high blood pressure, then they are restricted not to take salt much. So what will be the fact, or why it is told that high intake of salt in the diet is detrimental for the patient suffering from blood pressure? Only because of the fact that when a patient takes patient having blood pressure takes salt, so the intake due to intake of the high salt content in the food materials, the percentage of the ions in the body fluids will become rich in ion concentration, and that's why the pure water intake in our body will now pass from uh, uh, the cell or organelles which has already taken the salt. So there will be the passage of pure water intake from our body to the already salt taken by the patient suffering from blood pressure. So blood, in order to nullify the effect of excess salt, which results in high concentration of ions in the cell plasma, now water intake, which we have already taken water, will now move to that cell organelles in order to nullify the effect. So as a whole, there will be the high concentration of salt in the body fluid, and that's why high content of salt concentration will increase the pressure, and due to this the patient suffering from blood pressure should not take salt, and that effect is called edema. Next part is abnormal molar mass. So mass that is either higher or lesser than the expected mass is called abnormal molar mass. Now, why such things happens? It happens due to two reasons. One is for association and another is for dissociation of molecule. Now, let me take one example how association occurs, and that give rise to the increase in the molar mass than expected. Now see, it is seen that acetic acid or benzoic acid, when put in benzene, now this molecule of acetic acid becomes in this way. So it was monomer and it becomes dimer. Its atomic weight is found to be, molecular weight is found to be this, and when it dimerizes, it forms 122. Am I right? So in benzene, this polymerizes these two, though it is not exactly the same, but a bit less. Anyway, because of some other reason, I will explain later on. So acetic acid, when placed in benzene solution, then this acetic acid dimerizes as like this, and so also the benzoic acid dimerizes as like this. So benzoic acid, the molecular mass of benzoic acid also will be at least double, and that's why it is a molar mass of the substance either higher, it will be the higher. Again, this is called association, that has been associated. Now what is dissociation? Dissociation occurs when sodium chloride is placed in solution, it gives sodium plus chlorine negative, so ion becomes half. From single one molecule, 1 and 1 becomes half, so molecular of sodium chloride in this state will become half of original. So in this case we have got the abnormal mass, the molecular mass is half of the, not exactly half of the initial molecular mass. So the change in molecular mass occurs due to association or dissociation of molecule either in benzene or other solvent, or in aqueous solution in other solvent, and this is the reason the molecular mass of a compound shows sometimes higher and sometimes. Now, Bands-of equation for dilute solution. So Bands-of gave a established a equation, gave an equation which is for dilute solution. Now, how he derived the equation? He took one equation. So Boyle's Bands-of equation was pi, osmotic pressure. Pi is proportional to C is equal to concentration, and then on temperature is constant. And Gay-Lussac also gave the Bands-of equation as pi proportional to temperature. Bands-of theory for dilute solution is Boyle's Bands-of equation is pi proportional to C, and Gay-Lussac's Bands-of equation is pi proportional to temperature. So if you combine these two, pi proportional to Ct, or now pi is equal to CRT, and where R is equal to gas constant and pi is equal to C is equal to concentration equal number of mole per unit volume. Therefore, pi is equal to N by V RT, or pi B is equal to N RT, or we can say pi B is equal to total pressure, P is equal to nRT. So pi B is equal to nRT. It is the Bentov equation. Now another term is very important, very often appears in the exam. So Bentov factors I, where I is equal to normal molecular mass by observed molecular mass, and from this Bentov factors we can calculate it. We can get a lots of information there, that if I is equal to 1, if it is equal to 1 means it is ideal solution, and if I is greater than 1 means ions are greater than 1. If I is equal to greater than 1, it means that it is their dissociation occurs. If I equal to less than 1 means association occurs. So this is very important factor, with the help of which we can get the idea about a lot of information, a lot of properties. So again, you see that a relationship between I and alpha equal to dissociation constant, alpha means dissociation constant, so I alpha equal to Bentov factors. Then it is calculated that alpha equal to I minus 1 by n. If in the reaction association occurs, then I minus 1 divided by 1 by n minus 1. Very often question asked from here, alpha is equal to I minus 1 n minus 1 if the reaction dissociation occurs. So this is the relationship between I and alpha. So this is all about the today's topic solution, and in my next class I will explain about solve out all the problem within half hour. I will give you the trick and technique how to solve out the problems in solution chapter. Kindly subscribe the channel, because I am going to upload a lot of entrance exams topics after the exam is over. And also for the student, those who are going to appear in the higher secondary second hour, please follow the class number 10, 11 and 12, which is from organic, and this first year organic class 10, 11 and 12. This will be very helpful for solving out the problem of haloalkane and haloarenes, where elimination and substitution reactions are there. I have given a lot of information in this one. Also, for those who are the aspirant of entrance, please follow the first year organic parts. I have already done 1 to 16 classes, and these classes are all elaborate. So please subscribe, so from time to time you will get a lot of information for your exam as well as for entrance point of view. Thanks a lot for watching the classes.